Good morning, Mr. Clapton.
Hello.
Hello, this is Gina, and I'm helping Mr. Calvillo to take care of the test. Mr. Alejandro is going to be a little bit late, or might be a little bit late today because he's taking another makeup test for government, but he's here in the school, and he's going to be here as soon as possible to take the test for math.
Okay.
And he
So,
already took the makeup test, for you, and Mr. Calvillo already has a test, and he will be emailing to you here soon.
okay. Cool. So, um, I already graded. Oh, can y'all make sure microphone's turned off so we don't get feedback?
Okay.
Yeah, I already graded. I got the email while the last class was taking their quiz. So I went ahead and graded Alex's week 5 quiz. I sent him an email telling him that was graded. And so if he's um, um, and so what I understood was he's taking another test to make up for um, that he's trying to make up. So if he gets in here in time for our test, great. If he doesn't, just as soon as you can get that today's quiz out to him, that would be great. So does that work?
Yes, that works perfect, and I can stay with him later today so he can work on your test if he's too late, and I'll personally mail it to you.
Okay, sounds great. Thank you.
Thank you.
And ladies, how are y'all doing today? In the last class, some kid came in and asked them how they were doing. He's in the way back and started doing some sort of dance, and I was like, yeah. And so we had a little dance off. Of course, I won because I'm an awesome dancer. And
Mr. Clopton,
yes.
I was gonna tell you that on Monday, I won't be able to make it to class because I'll be at like a school day at Texas Tech, sort of like It's the Texas Tech preview. I'll be there from 7 in the morning to 4.
Okay. Cool. Enjoy your time at Tech. Um, enjoy your time at Tech. Take advantage of those opportunities to view the Tech campus and see what all Tech has to offer, um, and enjoy that. I wish I took more incentive when I was your age to uh, see what was available. See what was available to me. I grew up in O'Donnell. I don't know if y'all know where O'Donnell is. Um, but for me, Texas Tech was way too big. I was scared of Texas Tech. I was like, this is too big. I can't go there. But good for you for being brave and taking a look at Tech. All right, we're gonna take a quiz today, but I want to start. Excuse me. I want to start off with how can I address your homework questions. So we are looking at assignment 13, inverse functions.
No, sir, we're looking at assignment 12. 13's next week.
12. I got the name right, just wrong number. Assignment 12. What can we look at in regards to assignment 12? Anything?
Number 5.
Number 5. Okay, what do we got? Problem number 5. We have the function f of x is equal to the cube root of x minus 4 and we have that g of x is equal to x cubed plus 4. And we are trying to show that these two functions are inverses. So to show that f and g are inverses, we need to show two things: that f of g of x is equal to x, and g of f of x is equal to x. Those are the two things that we got to show. Got to show this, and we got to show this. So we're going to go through and show that both of these composition of functions equal x. So we'll start off with the f of g of x. So this means to take your function f, and everywhere we see an x, we're going to replace it with g of x. So we can all see that this is f of x, but I've just replaced this x with g of x. Now let's replace g of x with its equivalent expression. So g of x, that's g of x. And immediately we can see some things that start to happen. I don't even have to bring down the parentheses. We can clearly see that the 4's cancel each other out, which leaves me with the cube root of x cubed. And just like the square root of x squared, the exponents and the radical cancel out. Same thing in this situation. The cube root and the exponent of 3 cancel out, leaving me with just x. And that's what we wanted to show. So does that make sense how we got from f of g of x to just x? Does that make sense? Cool. So let's do the same thing. Let's do a similar thing for g of f of x. Let me find something real quick. Hold on just a second. Okay. So get my battery charging while I'm not writing. Alright, anyways. G of f of x. So we're going to start off with the function g, which is x to the third plus 4. And we're going to replace x with f of x. So I'm going to have something to the third power plus 4. And that something that we're going to take to the third power is f of x. So what is f of x? It is the cube root of x minus 4. And that's going to be raised to the third power. Then we have to add 4. And the same way that the cube root cancels out with the cube here, since all of this is being raised to the third power, the cube root cancels out with the cube, leaving us with x minus 4 plus 4, which then we can cancel out the 4's, and that leaves us with just x. So, since we showed that both f of g of x and g of f of x equal x, since we showed these two things, we can say that f and g are inverses. Does that make sense? Awesome. What else can we look at?
Number 12.
Number what?
12.
12. Good one. Okay, let's see. Number 12. Now, we did this in the last class, and I told them to know how to do number 12. I can change up this situation, just by changing up the numbers ever so slightly, and you would repeat the exact same steps that we're about to do here. Alright, so what we want to do is we want to find the inverse function f inverse of x. So if you've done problems 6 through 11, you saw that you repeated very similar steps. And one of the first steps that we took was we took that f of x and we wrote y in its place. And then what we want to do is we want to swap the x and y's. So every y becomes an x, and every x becomes a y. Alright, so at this point what we want to do is we want to begin the process of solving for y. We want to get y by itself. And when I look at this, I immediately think about this fraction, divided by y minus 6, excuse me. So I want to get rid of that divided by y minus 6. To get rid of that divided by y minus 6, I'm just going to multiply both sides by y minus 6. So on the right, those two cancel out. And on the left, now, there's been a couple of times in the past where I've said don't distribute the x, or don't distribute over here. Instead, leave things in the factored form, because in the next step you're just going to go through and divide by something, and distributing would cause a little bit of a heartache. But this is a particular case where we want to distribute. We want to distribute that x, and you'll see why here in just a second. So we have yx minus 6x is equal to y plus 5. So at this point we don't have any more fractions, which is what we like. The problem is I got multiple y's. And I also have multiple y's that are like terms. This has an x attached to it, this one doesn't. So I can't even combine these two y's together. But what I can do is I can get them on the same side of the equation. So we're going to go and we're going to get all of our y's on the same side of the equation, everything else on the other side. So we now have yx minus y is equal to 5 plus 6x. Now, like I said, you can't combine these two y's together. But what you can do is you can factor. You can factor out a y. You can factor out a y so that you now have y is equal to x minus 1 is not y is equal to, but y times the x minus 1 is equal to 5 plus 6x. Now, we're one step away from getting y by itself. We have y times the x minus 1. To get rid of that, multiplying by x minus 1, we'll divide both sides by x minus 1. So we now get y is equal to 5 plus 6x over an x minus 1. And that's how we get y by itself. And then we can go through and say, replace that y with the inverse notation. And we have 5 plus 6x over an x minus 1. Let's see. There we go. All right. So maybe I flew through that a little bit quick, but were you able to follow the process, the arithmetic for, yeah, good. So I, excuse me, like I told the last class, for a problem like this, you need to know it. You need to know how to do this. So I would, on your own accord, try doing this. Find f inverse of x for, all we're going to do here is we're just going to change up some numbers. So let's do 2 minus, or excuse me, let's do x minus 2 over, let's do x plus 2 over an x minus 7. Go through and do that on your own. Now, here's how you're going to check this. Here's how you go through and check this. So I'm going to grab out my calculator. Here's how we check this. So let's come up over here for f of x, and let's let x be equal to, pick a number, let's let x equal 2. So that means that we have f at 2. So 2 plus 5 is 7, and then 2 minus 6 is a negative 4. Which that's actually not too bad, because 7/4, a fourth is 0.25, so if you have 7 of those, or if you have 7/4, that's going to be a negative 1.75. Okay, so what I just did was we let x equal 2, and we got out a negative 0.75. And you can verify that real quickly. 7 divided by 4. 1.75. Okay, so that's how you get started. And now what I'm going to do is I'm going to come down here to my inverse function, and we're going to let x be equal to that negative 1.75. And this is where I want to use the calculator. So in my calculator, I'm going to show you this. So hopefully y'all can, I'm going to try to keep this so that you can see this. I'm going to open up a set of parentheses. 5 plus 6. I'm going to open up a set of parentheses. Minus 1.75. Negative 1.75, excuse me. I'm going to close the parentheses around the 1.75. I'm going to close the parentheses around my numerator. Divided by, open another set of parentheses. So we have the x right there, so that's going to be the negative 1.75. Then we have the minus 1 right there, minus 1. Now, if I hit enter, I should get the 2 that we had right there. I haven't hit enter yet, so let's go back down here. Oops. Let's hit enter and find out what happens. I haven't hit enter. Here we go. Enter. Ah, 2. That makes me so happy. We got 2. F inverse of x became 2. Yay! And you can do this for any values of x that so long that they're in your domain. You can do this for any values of x. So that's how you would test this. Once you find the inverse of whatever this is, go through and check it with your calculator. Just do a quick calculation and you can verify your result. Alright, so did that make sense what I was doing with the calculator? Cool. What else can we look at? Any other questions?
4.
4. Okay, 4. I wasn't laughing at y'all. I found something in my backpack that makes me smile. I'll show you what it is later. Let's see. Problem number 4. This will probably be the last one that we get to look at before we start taking a quiz. So problem number 4, like number 5, where given f of x, this case it's 3 over an x minus 4, and g of x is equal to a 3 over x plus 4, and we want to show that these two functions are inverses. So we're going to start off by evaluating f of g of x. So I'm going to start off with my function f, and where I see it x, I'm going to replace it with g of x. So g of x is 3 over x plus 4. And don't forget your minus 4 right there. So, very similar to problem number 5, those 4's cancel out. That leaves me with 3 over divided by 3 over x. So this is saying take a number 3 and divide it by a fraction. Well, how do we divide by a fraction? We keep change flip. So my shorthand notation for that is to bring this guy up, but flip it. So they have 3 times x over 3. Now, this 3 is a 3 over 1, so we can see now that those 3's cancel out, and I'm left with x. Okay, does that make sense? Did you follow that? Good. So we just showed that f of g of x is equal to x. Now what about g of f of x? So g is 3 over x, so I'm going to replace that x with f of x. F of x is this 3 over x minus 4. So just like we had over here, we have what's called a complex fraction. We have a fraction that has a fraction in either the numerator or denominator or both. So to take care of this, I'm just going to think about dividing by a fraction. So we're going to bring this guy up. So now we have rather 3 over 1 times the reciprocal of this, so it's going to be x minus 4 over 3. Don't forget about that plus 4, and now you can see what happens. The 3's cancel out. I'm left with x minus 4 plus the 4. The 4's cancel out. And now we have equal to x. So, we have just shown that f of g of x and g of f of x both equal x. So since they both equal x, we can then say that these are inverses. Alright, so does that make sense? Alright. Welcome back, Alex. How are you feeling today? Yeah, good? Alright, so at this point, we're going to just spend the rest of our class taking our quiz, week 6 quiz. So I'm going to ask the facilitator to get that passed out. All the material needs to be removed from your desk, and you know what to do. Scan your quiz when you're done. The Dropbox folder in Blackboard is available to you, and what was I going to say? That's all I got to say. So we'll start next week talking about assignment 13, quadratic functions and inverses. If you have any other questions over assignment 12 over the course of the weekend, feel free to email me. Remember that material this week is going to be due 11:59 p.m. on Sunday. All right, so go ahead and get started, and I'll just be here. Okay, are y'all done with the quiz?
I'm done. Eric,
Is everybody done? Or no? Okay.
We have two that are still working but are almost done.
Okay. Well, y'all are wrapping up the quiz. I'm going to be packing up and headed out of here. Uh, y'all have a great weekend. Uh, we will spend next week. Remember, we're only going to be meeting on Monday and Wednesday of next week. Um, and we'll start off on Monday talking about assignment 13. So please come to prepared for class by having looked at the notes for assignment 13. And we'll go from there. So y'all have a wonderful weekend. Take care. Bye.
Your conference is scheduled to end in 2 minutes. Your conference is now over. Goodbye.